Okay, so we're going to take a look here at 13.5 day 2, which is graphing a tangent and cotangent. Okay, the homework's actually 1 through 4. I didn't update that, but anyway, you'll see it. Okay, here's the deal with our tangent and our cotangent. These actually a primary cycle of these, so one period is just going to be 180 degrees. And let me talk about why that is. Okay, here's the deal. Think about the tangent as the y over the x. Okay, so y over x. In this case, we're looking at 0 degrees. Okay, so the y over the x is the 0 over the 1, right? Which 0 over 1 just equals 0. Okay, and then over here we're talking the y over the x, the 1 over the 0. That's undefined. Okay, and here the y over the x is the 0 over -1, which is just 0. Okay, now the cool thing about tangent is the tangents at 45 equal 1, right? Because we're talking root 2 over 2 over root 2 over 2, which equals 1. So the tangent here equals 1, and the tangent here equals -1, right? So we can see that we go from 0 to 1, undefined, to -1 to 0. That's one cycle. If we were to go down here, we would be +1, undefined, -1, back to 0. So we can reach the amplitude, the negative amplitude, and back to where we started in 180 degrees, just like you did with the other trig ratios. Okay, so that was for tangent there. Okay, so that's tan. Okay, I'm going to draw another one over here and do cotangent, and it's going to be pretty quick and simple. Okay, we'll do that. That didn't work, but we'll deal. Oh my goodness, everything slipped out on me. That's awful. I need to redo that. I'm sorry. Okay, let's see if I can do better. Better circle. Not very good line. Not very good line. Okay, whatever. Okay, so on a cotangent, okay, well, what's the reciprocal of 0? We've talked about this before. It's undefined. Okay, what's the reciprocal of 1? 1. What's the reciprocal of our undefined? This would be our x over our y. So we're 0 over 1, which is 0. Okay, and here we'd be at -1, and here we'd be undefined. Okay, so that's our cotangent. That's how that works. Okay, let's get into the graphs a little bit, talk about it. Okay, notice that tan and cotan curves repeat more often than sinusoidal curves. If the period is considered to be the width of one section of the curve without repeating the y, okay, that's what we just talked about. So here, a period is, instead of our 2 pi over b, our period for our tangent and cotangent is just pi over b. Okay, that's really the only difference in these graphs as far as setting up everything. Okay, so primary cycle is still considered our h, and then our h plus the period as one primary cycle. So we're still going to do period over 4 for our each notch. Okay, here we go. Let's take a look at our general look at a cotangent, or excuse me, as a tangent. Okay, so here is a tangent, right? Start at 0, go up to the asymptote, which is the undefined. Come back here. I like to start over on this side, start at 0, come back down, okay, towards negative infinity. Okay, so that's what your general equation is going to look like, or your general graph is going to look like for a tangent, right? We still have our k. We still have our k plus a, k minus a that we need to highlight. Okay. Now down here on a cotangent, we have our asymptotes on the outside, right? Our undefines at the reciprocal of 0, and then we have a little curve going through there. Okay, and we'll talk about that. I've got a couple word tricks to work with, and I'll give those to you as I graph these coming up here. Okay, let's take a look at an example. All right, right here, Let's get into it. Our K is 2. Our H is 1. Our amplitude, 1/2. Our B is pi over 6. Now our period has changed. It is pi over B for our tangent or cotangent, okay? So we are talking pi over 6. Flip and multiply, we've got pi times 6 over pi. The pi's cancel, we just get 6. So our each notch, and I'm going to erase this and put it just to 6. Six for our period. So our each notch is still the pi over 4. Excuse me, the period over 4. So we're 6 over 4, which is 3/2. Okay, that'll be interesting. We'll be, doing our x-axis in 3/2. So just watch how I do it. I've got kind of a decent way to handle this. Okay, so let's get to our graph here. Setting them up just the same. Boom. My K is at 2. My amplitude is 1/2, so I'm just going to bring this down right here. Okay. K equals 2. Dashed line through there. K plus A equals 2.5 or 2.5 plus A. K minus A, we'll call it down there at K minus A equals 1.5. My pen's not working very well right now. Anyway, that's our setup. That should be really easy for us right now. Okay, little tricky here. We're counting by 3/2 as we go, okay? So our H is at 1, right? Which 1, I'm going to call it as 2 over 2 because we are adding by something over 2. So now I'm just going to mark it as 1, 2, 3, 4. Extend that, see if I can get it. Okay, so add 3 over 2 to each of these. So I have 2 over 2 plus 3 over 2, that's 5 over 2. And then plus 3 over 2 is 8 over 2. And then plus 3 over 2 is 11 over 2. And then plus another 3 over 2 is 14 over 2. And you're probably going, oh, well, look at that. We've got an 8 over 2 and a 14 over 2. Can I just call those 4 and 7? And the answer is yes. 4, 7 right there. Everything else I just keep as an improper fraction like that. Okay, tangent. Here's how I graph a tangent. Okay, I go think back to this, what we looked at right here. Undefined is in the middle at 0. Okay, so here's what I do. This is where the word trick comes in. Take a look at this. Tangent. What's in the middle? A. What does A stand for? Asymptote. Okay, so in the middle of my graph, I'm going from here to here, and I go whap into the middle right there. That's where my asymptote's going to be. So I'm going to mark that. Bang, asymptote. Okay, and then I always started K plus A, or excuse me, at HK right here. Okay, and the first mark is up 1. Boom, right there. And then I go over here to the other 0, and then I go down to the amplitude and mark it that way. Okay, but I mark my asymptote first, okay, on either one of these, on a tangent or a cotangent. And how I remember that the asymptote is in the middle of my tangent is that A is in the middle of tangent. Okay, it's also going to work here because 0 is in the middle of cotangent, and you got an O there. Anyway, All right, here we go. Sorry, I'm taking up too much time. Okay, let's get into here. We've got K equals 2. H equals 1. Amplitude equals 1/2. The B equals pi/6. The period equals pi/pi/6. So pi over B is our period for tangent or cotangent. So that is going to equal pi/6, which just equals 6. Okay. And then we go down here, and it is the period 6/4, which equals 3/2. So we're going to have the exact same graph we're working with above. Okay, everything was the same. Great. But the only difference is we're working with a cotangent. All right, here we go. We've got our graph. I'm going to set it up like this. Line there, line here. Got a guessed. Okay, so K is at 2. 2, mark it, dashed line. K plus A, 2.5. K minus A, 1.5. Again, for me, the scaling doesn't matter. I want to see the numbers. Okay, we've got our H, and then 1, 2, 3, 4. Every time. Okay, so what's our H? 1. And what's our each notch? 3/2. So I'm going to go here and get a common denominator. Call it 2/2. And then again, we're adding 3/2. So add 3 to the numerator, 5/2. Add 3 to the numerator, 8/2. Add 3 to the numerator, 11/2. Add 3 to the numerator, 14/2. And again, we can call that the 8/2 4, and we can call the 14/2 7. Okay, now we're looking at a cotangent. What's in the middle of cotangent is an O, a 0. So in the middle, I go from and if I had 2 hands to show you, I'd do it. Okay, I go from here to here, and I go, whap, what's in the middle? Right there. Okay, so now I go, right here is my O. Okay, my 0. Okay, and on the outsides are my asymptotes now. So here's an asymptote, there's an asymptote. And then if this is positive, I just go from the amplitude here to the amplitude there. So I'm going from the top and then a little swerve and then down out the bottom like that. Okay, what I'm looking for, make sure that your numbers are correct. The scale to me doesn't matter that much. Have it equidistant between here and here, and then have your H and then your 5 notches as you go. Okay. A cotangent looks like that. A tangent looks like this. All right, very good. We'll have a meeting on Tuesday at 10. Enjoy your long weekend. Take a look at this, see what you can do. All right, and we'll go over this on Tuesday's meeting at 10 o'clock. See ya.